The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
Welcome, everybody. So this is the one group meeting that we'll have with all you folks. We really appreciate your willingness to come and help us teach 6172. Saman will explain what the course is all about, and then I will give a presentation, a little bit of what your expected responsibilities are, and then Eirik, who is one of our TAs, will present what the first project that they've been working on is all about. We think we have a pretty good and apt acronym. Okay, MITPOSSE. Okay, Masters in the Practice of Software Systems Engineering. Okay, and it is very much like a posse in that we're sort of deputizing you folks to help us deal with this mass of students that we deal with. There's no way, given the resources that we have available at MIT, that we could possibly give the attention to each of the students' examples of code. And so our strategy is to go out and deputize some people to help us teach. As we'll discuss, your responsibility is not to do any grading, okay, or even any understanding of the course content, okay, but rather to ask good questions of the students so that they understand what it's like to do software development. And you'll see that most of the students are very immature when it comes to coding practices, okay? They have taken one minimum of one systems course before this, basically.
And probably two classes where they write very small programs.
Where they write like very small programs, so they have no sort of sense of writing scale. Moreover, the class that we're teaching, because it's on the topic of performance engineering, they are inclined to break all the rules in order to get the best performance. Okay, and that's part of our game, but of course what we want is the countervailing, you know, you still have to make things maintainable. You really should do it this way. Yeah, it's fine to violate some abstractions here and there, but then you should document that you're violating those abstractions and so forth. And that's what we're counting on you for, is to insert some experience and common sense. So, Saman, take it away.
Okay, good. So, to add to what Charles said, when I was undergrad, when I took something like a science class or a physics class or engineering class, most of the problems that there was kind of a right answer and a wrong answer, and then it's very easy to grade those things. But when I took something like an English class, all the papers I wrote, somebody really went through carefully and graded it and gave me a lot of insightful comments, so I can kind of develop my own style of writing. And what happens in software is the programming, there's a style that every individual has to develop their style, but they can't develop a very haphazard style. So there's a certain set of good styles, certain bad styles. And the problem that is in a large class, we can grade for correctness very easily. We can also look at the programs and have a very fast thing, okay, saying you have no comments, or your comments doesn't seem to be, it's too verbose, or some very high level feedback. But it's very hard to help somebody build their style. And so what you guys are coming into is to help us get these young students create their own style of programming. The nice thing about this class, and also sometimes last year the masters found it a little bit hard, was we are giving them small amount of code. They are doing performance engineering on maximum couple of 100 lines of code. There's no very complicated class structures or something like that. So we are not looking at the style and software engineering in the macro level. how do you structure large classes, but more at the micro level. Okay, in each method, do they have right style? Are they is it clean? Are they commenting them properly? Can they do it better? So at that level, at least the building blocks that as they go build a larger and larger program, they can hopefully use. So that's what we are looking at, and it helps you. Instead of dumping you 10,000 lines of code, you only get a couple of 100 lines of code. So you can actually go through it a lot more carefully and help them out. So this is starting with a crazy eye chart that is our new curriculum that we introduced in the department. So what you have is some early courses in here. These are basically very general math courses, early courses that they probably write 10 lines of code type thing in these courses, and then we feed into these foundation courses, and then after that we sit at this says 197, actually what should be 172. We sit at that level. So basically, oops. So we are sitting at that level, and then the prerequisite for people who are coming is they have taken a computer architecture course, so they know a little bit about the architecture. They have taken this introductory software course, so they have written some Java programs, and so they know a little bit about software engineering from that course. And they have taken algorithms course, so they understand algorithms somewhat. So this is the background of the people coming in. At the low end, there might be some people who have only written a couple of thousand lines of code in their lives, and there are other people who are written half probably the Linux kernel. So there are kind of very diverse high group of people. So but there are some people who it's really new to them, and they don't even understand why you have to do good nice programming. Why do you have to document these things? I mean, for them it's a very new concept because they haven't seen that. So okay, if you are running 10 lines, okay, why do you need to document that? I know what it is, and so part of that is for a lot of them it's eye open. And in last year also, when you talk to students, they actually gained a lot from talking to you guys. It's easy for us to tell them do it, and a lot of them say, okay, just to get the grade I will do it, but after that I'm never going to do these things, and they just go off in very mad at us for asking them to do it. But when you guys say this is what happens in industry, there's a lot more impact on what they are going to do. And so I will go through very fast. So we have done a case study on matrix multiply, show doing how you can basically do things like algorithmic tricks, architecture tricks, and stuff like that, get really good performance of matrix multiply. So we started with doing very object-oriented, immutable type matrices, matrix multiply, and then got down to doing BLAS. How much of performance gap do you think that has?
It probably depends on how big the matrices are. Because
yeah, it's just a 2K by 2K matrix. So it's a yeah. So somebody is 2 orders of magnitude.
10x.
Yeah, 10x. So actually, in fact, since I started with the immutable matrix, very object-oriented stuff like that, and then did all the optimization I can do, I got 300,000x. So this is kind of a extreme case, but it illustrates how much kind of performance sometimes is hidden in these applications. And then we talk bunch about these are done lectures. Talk about some very simple things in performance engineering. Okay, how to optimize loops. What are the things like how to get the compiler to do certain things. Some basic facts. We have a bunch of rules in there that we went through fast. And we are going to do introduce them to performance analysis for a lot of these people. First of all, they don't even know their code is running bad because they don't know how to look at it other than getting one num bad then. Even if they know their code is running bad, how do you go about figuring out what's going on? They know a little bit of a GDB, but they don't know anything about performance analysis, so we are introducing them to tools in here. And we are talking about C to machine code. A lot of them are Java programmers. We already gave them a C primer saying if you're Java, what does C mean, kind of a thing. And I actually talk about computer architecture today and talk about the Intel process they are going to use. They are using this Nahelm process and all the interesting things that happen inside the processor that they have to be aware of. And the same way we are going to talk about the memory system optimization. And then Charles is going to talk about algorithms and data structures for caches in there, and some about storage allocation, We'll have a bunch of lectures on parallelism that Charles is going to use Silk language to illustrate how to write parallel programs. That's what we are going to use in this class. And then more on parallelism, things like data synchronization issues, and dig deep into other performance issues in parallelism in there. And then since their final project is on ray tracing, we'll introduce them to a ray tracing primer and say how ray tracing is done, and so they can go into their final project. And then I'm going to talk a little bit about compile optimization, what compilers can do for you and how to get compilers to do those things for you. And a little bit about distributed systems, so how can you scale out? On to this point, it's about getting a small piece of code to run fast. Now, how do you get millions of users go to this very large scale systems and get them to work, and what issues are involved. And then we are going to also have about 3 or 4 case studies sprinkled around. We'll get somebody from university come and talk about specific problems. Okay, look, I had this problem, and at the beginning it was bad. Here's how I went about figuring out why, and here are the things I tried. These are things worked, these didn't work, and how we went go. So kind of a very hands-on case studies about doing performance. I think that will, because what these people has to do is develop a methodology, their own methodology of how to go about solving these problems. And looking at these case studies will give them a feel how a very experienced person will go about looking at some of those problems. So these are the kind of lectures we are doing in a nutshell. So the projects we are doing. So students' mission, what we do is we write some inefficient piece of code, not that long, and we give them to students, say, okay, this is functionally correct, but it runs dog slow. And what you can say is, okay, take advantage of right now the first project is basically looking at algorithmic and data structure inefficiencies. So okay, trying to find better ways of doing that and change this program to run faster. So that's their thing. So they don't have to deal with thousands of lines of code. Small program, it's correct to run them fast. And this year also we are asking them to write tests, so you can actually test their implementations and make sure that implementations are also correct. And basically there's no right answer. This drives students crazy because they're like, when am I done? I'm like, you're never done until the deadline, because you can keep doing more and more, and you can keep increasing performance in there. And of course, if you hit very marginal returns, and at some point you might decide that, okay, that's good enough. And also, most of the times the journey is as important as the outcome. So at the end of the day, you can say, I got it very fast, but how did you get there? What's the process you followed? Some of these easy programs are easy to get there, but if you haven't learned that process, you can't scale it out. And so a lot of times your part is to talk to them and say, what did you do? And say, okay, look, why did you skip that stage? Why didn't you profile? And get them to do that. And someone say, yeah, I just look at it, I realize what it is. Like, okay, no, just do something. There might be something hidden in there. So get through the process, understand the process. That's important. So the way projects work is, we give them a project, we start in the project, and there might be some projects have 2 parts in there, and final and project requires a design document for them to give us saying what they figure out what's bad and what kind of optimization they are thinking of doing in this project. And then we have a thing called a beta turn-in. They said, okay, look, we ran this, we got that the project and turned the project in, and we call it a beta, because I'll tell you why. And then what we do is we run everybody's project against everybody. Basically, we run every project, and we figure out who got the fastest out in implementation. And we said, okay, we announced that, so this is the fastest implementation. And then we figured out how off are you from the fastest, and we have a portion of the grade that's basically comparatively graded. So if you get the fastest, you get 100% in that. On the other hand, if you are 10x slower, you get 10%. Except the first time we tried, the fastest was 1000x better than the slowest. So somebody got like 0.1%. That didn't work, so we are doing square root of the performance. So there'll be a little bit more in there. Somebody can't get 1000x there. And then, so sometimes it's because somebody just missed one critical insight. And and also they might not have done the test properly and stuff like this. So we give them opportunity. And then after this beta turn-in, you get this code, and the TS get this code to run and do a very fast check over that and then they are going to have a week to find a time with you, sit down for an hour or 90 minutes and go through this code. And then they will get all that feedback, the performance feedback, and they can talk to people and figure out what they missed. And they get another chance to fix all those things, get the performance up and turning, and there will be another performance measurement. But now, if they match up to that point, they can get full marks. Of course, if people exceed, they can't get extra, because then that will be a little bit too because we want to limit the competition, but at least you get a chance to kind of match up to the best code. So what you have is this design review week that they get to talk to you and get feedback, and then after that they fix everything up and they resubmit it.
You should mention the beta tests.
Yes. So what also we do in this is we are asking them also to create a test suite, and we are going to run everybody's programs against everybody's test suite, and also give them points on coverage of their suite, and also how well their program does against everybody else. So if somebody finds a lot of bugs in other programs, or there's a test that found a couple of bugs that nobody else found, we will give a lot of points for that person, because that means they went and did a really good job in creating test suite. So we are actually using that to basically emphasize on testing and testability issues in there. And then finally, when you turn in, then the TAs will at that point will grade for performance and also the coding style. So at that time they will go through the code and assign a grade, and so if the students have listened to you and carried out what you said, they should get really good grades on that part, and then they had to also provide a write-up in that. So this is the kind of the flow of the projects we have. And the project 1 is simple algorithmic and data structure tricks. So we did things like data rotator, bit flip counter, and this Pentomino's puzzle that we're going to explain a little bit. So we gave these things that we have a pretty inefficient representation, where most of them has a much better bit representation, and you can do bit tricks to basically get good performance. So these are algorithmic and data structure representations that can have huge performance gains. So this is the first project, and this is what next week you are going to get. So project 2 is more about memory system performance, things like image rotator and number sorting. We have 2 parts. The first part is we give them these problems, and they are supposed to run with different data set sizes, look at performance counter results, and identify what's going on in these programs. So there's one thing that we will give them bunch of sorts compiled, and they have to figure out which sort is which by looking at performance counters. And different runs. So you have to identify. So basically give them idea to basically observe program behavior, and then we ask them to go and fix some of the performance issues as the second part. So this is a lot about basically getting performance information, understanding a lot of hardware what's going on, and then going and doing some performance fixes. So there will be 2 parts to that project. And the project 3 is implementing efficient storage allocator. For most of these students, after they are done with Java and Python, they come thinking there are these objects running in memory with thing called pointers that points to, and to understand what a pointer is sometimes hard. And this is an interesting example that they are actually doing a lot of pointer manipulations, and you have to get a lot of those things right, and you have to have good discipline to do that, as well as getting some performance. So this is an interesting project in there. Here you don't get too much of performance variance, but students have to think very carefully about basically aliasing data structures and stuff like that. And so getting but some of these dirty little things you have to do and learning how to do it right. And then we go into parallel programming. So first part is introducing the concept of parallelism, giving them some simple programs to basically parallelize. And then the second part is we give them insertion detection. We are inserting bunch of lines into a image, and then they have to figure out when these lines move, when they actually intersect. And so it's not embarrassingly parallel. You have to actually do by intersegmenting the data into regions and basically figuring out where communication is needed. So there's a lot of issues in there. You have to get it done. It's a fairly complex program that they have to deal with, and so they are going to have to think through a lot of parallelism issues, synchronization issues, communication issues. All those things come into play in here. And then project 5 is just a problem set. because we want to make sure that they understood some basic material we teach. So you don't have to deal with that. We give them actually write up. They don't have to do any coding in there, and they turn that in as a normal problem set. And the project 6 also, you don't have time to critique that because it is due at the last day of the class. But if you are interested in basically giving them some feedback, or just come into the finals and see how they do. So there what we do is, this is really fun project. We give them a very unoptimized ray tracer, and we say, okay, here's an image that it can generate. If you generate image that looks the same to us, you will be okay. So you can change the algorithms you are doing, come up with other things you can do where you can still maintain the visual equivalence. And then you can do that, you can optimize, you can parallelize, you can do anything you want, and build a ray tracer. So they go, and then we explain them the basics of ray tracing, and they do a lot of cool things, and a lot of these kids actually really change, think through algorithmic issues, look at a lot of graphics, and find the different ways of better ways of doing things, and come up with really cool tricks and do really well. So for that, we will invite you guys to come to then we will have basically bake off. Everybody will come and figure out who has the fastest ray tracer, and they have the bragging rights as well as the grade of having the fastest ray tracer. So
I'm going to go through this.
Okay, you go through the other schedule here. So the most programs are done in C and very little C++, not very complex C++ classes or anything like that. We want them to be very close to the metal. They have been trained in a lot of abstract programming in Java, Python, and stuff like that. Now they are going to get to the metal and understand things like pointers, malloc and free, native data types, and stuff like that. And we are not dealing with things like dealing with garbage collection and bounce checks and all the other things. So they're really seeing what's going close to the metal. Sometimes we are even encouraging them to look at a little bit of assembly, but that's not really required. Okay.
Have these students had exposure to any kind of assembly language programming?
In 004, they are using some assembly programming in the architecture class. But I think it's a very simple, I think, RISC type machine instruction they are doing. So and then we will have our course website. As you go about, you can look at what the course is doing, and also if you change this FA10 to FA09, you will see last year's code. So you can actually even see into the future what we have been doing. So if you want to kind of prefetch in the front.
I took a look at this website and found that most of it was unavailable because of.
We should have world readable. We need to make sure if it is not world readable.
When did you?
It says it's world readable.
Oh,
some of it is. A lot of it was not. It said you need to. And it's only
Certificate.
available for.
Certificate.
Okay.
Okay, we will check that because there's all this thing that we had set up in the background to get everything world. We want to make everything world readable, so we'll make sure that happens. So okay. So that's all I have about the class. And one thing interesting in most of these projects, the best to worst can sometimes be 1000x difference. So what that means, even for the people who are struggling, they can get something out of the class. But unlike other classes where you just read the limit and then you are bored, you can really keep pushing the limit, especially things like the final project. The people who did well really pushed the limits. They could have done that for a graphics class type thing. I mean, they pushed algorithmic changes, did amazing parallelization techniques, data partitioning, everything. And whereas some people just kind of stay within that and did some small parallelization, got some like low-hanging fruit in there. So this class has, I mean, what we are trying to do is in computer science these days, we get some students, as I said, their first time they are coding anything more than 10 lines, and other people who are already in a submitter for open source projects who have written millions of lines of code. We have this group. And this course, I think we are trying to cater to at every level and keep everybody basically very motivated and excited in there. And I think the last year it was a pretty good success, and they really all enjoyed the meeting the masters last year. And after we go to the discussion, we can talk about that a little bit later.
So we have two websites, as Saman mentioned before. So here they are. And then here's the schedule. So let me, we'll run through this in more detail for what is expected of you in a moment. But basically, there's 4 projects that sort of are organized along here. Whoops, that typo didn't get fixed. That's should be November 19th, obviously, there, instead of October 19th, if you want to correct that on your calendars. Okay, so in general, it begins with an information session, which you're allowed to attend in person, but most people just dial in. It's more convenient. Then we will provide you with the beta code submitted by your 4 students, and then you'll have 2 meetings that typically are 60 to 90 minutes with each of your 2 pairs. Okay, and so so let's go through how this is working. So the first thing, so now let's get into the content here, okay, for what is, so the first thing is just to make sure you folks recognize that you're making a commitment. It's very difficult for us, and it's even more difficult for the students to cope with something that happens midterm, okay, where suddenly their master disappeared or whatever. And so, so we're very big on anti-flakiness, if you will. And so if you believe that there's going to be a problem, please let us know as much in advance as you can. Sometimes things are unavoidable. They come up. We don't fault you for that or anything, okay? Just let us know. We'll try to deal with the situation. But for the most part, we're really asking you to make a strong commitment you know, to the class. And so if your situation is such that you're unsure, it's best to talk with us or politely decline to participate rather than saying, you know, putting on the rosy glasses and saying, oh yeah, I think I can do this, even though I know that I've got a major deadline that conflicts with one of these projects or whatever. It's just really difficult on the students if when things change. They're sort of going, I don't know if you remember what it's like being in school as an undergraduate, but pretty much the students go sort of hand to mouth in terms of, you know, they look and they say, okay, I got this deadline this week, I better work on that one. You know, they don't really look ahead and so forth. And so it's up to us to some extent, you know, to recognize that they're in that mode and that we need to do things to make that easy for them. You know, when they get sick or something midterm, it's really, you know, can really throw a student way off for the term. And so certainly when the staff, something happens to staff, that's, you know, that's sort of at that caliber, it can really knock them off their, you know, off their trajectory. The design and code reviews should normally be held at MIT, okay? And you can, the students will have some locations. That will be, if you are within walking distance to campus, however, you may suggest an alternative place to meet, such as at your own workplace, if that's more convenient for you. Okay, but if a student balks at doing that, you shouldn't pressure them to accept. The content of the off-campus meetings should be professional. It's strictly the review process. No lab tours, no free lunches or dinners or what have you. Okay, and we'll talk a little bit more about that later. But the main thing about them is that they can be scheduled in the evening or, you know, whatever time you and your 2 students find convenient to get together. Okay, there's no limits as to when, you know, what time those can be. They can be on the weekend. They can be, you know, whatever you can work out. Very flexible. Okay. So here's the basic guidelines. Each master is responsible for reviewing the code produced by 4 students. Okay. The students typically will work in teams of 2 or 3 for the projects. Okay. So what you will have is your 4 students will be organized into 2 review groups of 2 students each, but none of the students will be on the same project. The reason for that is that we want to make sure that every student who goes to represent their project can represent the whole project. Okay, so they're responsible for the whole project. They don't have a buddy there on the same team who can cover for them when you're asking them questions about their project. You ask them questions, they've got to be able to answer about their whole, the whole thing, even if they didn't code every piece of that. We're encouraging them generally to do things like pair programming. Okay, so they really should understand, what's going on throughout their throughout. The reason for having two groups, rather than meeting them individually, it turns out there's actually some good knowledge of one of them sort of being able to see what the other teams are doing. So generally, they're not allowed to share their solutions, et cetera, with other teams. But in this meeting, that's okay. Okay, the ideas and so forth can come, but they shouldn't be making copies for each other of the code of the other group. But they can say, oh, is that what the other team did, and so forth. And there can be some learning for them to submit the final project.
Also, last year, a lot of masters very successfully used the other team members to kind of critique each other. So showing something and say, do you understand this? And then they can look at it and say, yeah, I can see what is going on. That's very useful. Also, I think when we go to masters, we can talk about how that happened.
Yeah, also things like, documentation. You can look at the code there and ask the other one, do you understand what that documentation, says and so forth? It turns out it's actually, easier than that, because usually if the documentation is inadequate, the student himself has trouble remembering what they did, right? I mean, you know how this works with code. So, so consequently, you're responsible generally for 2 review meetings for each of the 4 projects. Now, as it turns out, we'll assign things. We're going to have things like students dropping the class, and so there will be some minor reshuffling as we go on. Some of you may end up with only 1 team of 2 students. Some of you may find that you're reconstituting it. In some cases, if we end up, we may ask somebody, can you cover an extra team this time because somebody's going to be out of town or something like that. So there may be some variations on this, but this is basically how things go. Now, one thing you should understand is that you are not going to grade the students. Okay, so one of the things I learned long ago was that when you grade, when you grade somebody, they behave differently than if you don't. Okay, so you're not grading them. That has a plus and a minus. The plus is that then this is really pure feedback for them. Okay, this is to help them. They know that you're supposed to do it right. The downside is, then they say, some students will say, then I don't need to listen. Okay, because nobody's holding a stick over my head. Okay, but the reason we do that is twofold. One is because we think that the quality of interaction is better. And the second reason is because you're not empowered by MIT to give grades. Okay, so you won't be grading them. You're also not responsible for the technical content of the class. We're going to be teaching stuff, hopefully, which is sufficiently new, some of it, that some of you may not know all of what we're teaching with respect to parallelism and so forth. Some of you may, that's great. But that's not at all, that's not the role. We will take responsibility for teaching the content of the class. What we're really after here is for you to listen as an experienced program developer and provide feedback to the students about software engineering. Okay? In other words, explain to them what's going on. Well, why didn't you write that in your documentation? How come all your variables have only 1 letter? Okay, why is there, why is this stuff, wrapping around 3 lines before why no white space? This kind of stuff, okay? So remember, these are very immature, they're very smart students, okay? But they're also very immature, many of them. Some of them you'll discover are like way mature, okay? But there's going to be some of them that are just absolutely, this is new to them. And what they need is some encouragement and some suggestions as to what they can do to improve the quality of their code. And since we're not in a position to review it, what we're relying on you folks is why we're deputizing you as members of the MIT posse, is to deputize you to help them produce better quality code, okay, which is not something that's easy for us either to give feedback on or to grade. So hopefully that when we are grading them in the end on their final submission and the quality of things, it reflects that they've learned something from you folks about producing good code. It's often also, you want to be careful. This is one of the bugs that I have when I interact with students is I tend to do most of the talking if I don't check myself. Okay, and one of the really good things is to have a guideline that they, you know, I don't know how many of you have teenage kids, and you know, if you lecture them, how quickly they learn, right? You know, no, they don't. So the goal here is to help them learn. Okay, and so lecturing usually doesn't work. What works generally is getting them to do the talking. And then it's great to pepper your interactions with anecdotes. You know, I worked with one person who did this, or early in my career I did this, and here's how it blew up in my face. Okay, that kind of thing. Excellent to have anecdotes that you can give with real world experience why you might think it's like this, but in fact, if you do it that way, you're headed down, you know, a very bad path. Let me tell you a story about that. That's fine, okay?
Or if you find a very stubborn person saying, if you do that, I won't hire you.
Yes, right. That helps too. Yeah. Okay. You would never get a job here if you coded like that. Okay. In fact, that's actually what Saman says. That's actually one of the big benefits of having you folks from industry providing that feedback, because we can say that. If you do it like that, you know, you wouldn't be hired by, you know, XYZ Corporation, okay? You can say that. But if you say, you know, I wouldn't hire you if you did that, that has a, you know, it's like, oh, I'm, you know, it has a big impact. Whereas when we do it, it's like, you know, it's like, you know, what do they know? Okay. Okay, so the guideline is make them do a lot of the talking so that they're trying to explain, and you teach them a little bit what a design and code review is. Now, in fact, what your review is both design and code review.
So to add to that, what we have told them is to prepare for about a 5-minute statement type thing to walk through and explain what they did to you guys. So they will come with some preparation stuff that they can do that, let them, both of them kind of do that, and then start more of the interactive part.
Okay, so and maybe they'll do that. Okay, but that's the goal. Is you should say, look, when you come, you should prepare something that brings me up to speed, and teach them a little bit about what's expected of them when you have a design or code review in industry. So for each of the projects, as we mentioned, there'll be a short information session, typically by dial-in conferencing, except for this one, which we'll do in a minute. After the students have submitted their beta releases, we will get the course, the code to you. Last year, we had the students responsible for getting the code to the MIT posse, and that was basically a nightmare, okay, for everybody involved, okay? So this time, we will make sure that we get you their code, and I hope that way the unreliability, I don't know if you remember, but like these are mostly like juniors and seniors, okay? And when you're juniors and seniors, you're not 100% reliable in everything you do, and your word is your bond is not necessarily, oh, I forgot that my word is my bond kind of thing, right? Okay, so, so by us getting it to you, we'll remove one layer of, hopefully, of flakiness. Next, what you'll do is you'll coordinate to meet with a mutually agreeable time, okay? And then after the review, you're going to provide us with a little bit of feedback. It doesn't have to be long, just a short email, not as a grade or evaluation, but to help us understand where the students are doing well and what they're missing, so what we may need to stress in class and so forth, okay? And then, of course, after the review, they have the opportunity to make changes to their code before they submit their final revision. Now that's a little bit different from industry, where you would go through typically some kind of feature freeze and code freeze and so forth. Our beta is not that. It's beta sort of in name, but not necessarily in all aspects, in that they can actually completely rewrite their code between the beta and the final version. Okay, so.
So in your feedback, if you can also tell a little bit about in your interactions what worked and what didn't. This is the first time, as far as we know, anybody is doing this kind of a thing anywhere, and so we are also developing a process. So good practices is very interesting.
Yeah, and since your email will go to MIT Posse and everybody will read it, okay, what hopefully you can do is some of the practices that you find useful. I tried this, it worked. I tried this, it didn't work. That starts to get spread out among you, and it becomes very helpful for each other to say, oh, well, that was an interesting idea. Let me try that. And so we hopefully will be able then to start compiling some best practices.
The students by name in those broadcast emails.
Yes.
Okay.
Yes. In fact, here's the thing: is what you're going to do is give bullet 1 names of the students who attended, and that helps us keep track of who's actually going to these and who isn't. Okay. The strengths and weaknesses in the student presentations. Some suggestions for improving the assignment. That's suggestions for us to improve the assignment for them. Okay. And any other comments. Okay, so we got some really good feedback last year that, hey, the code you're handing out as the initial code, that was really sloppily documented. Okay, last year we were much more behind the 8 ball in terms of trying to do this. This time we've had more time, and in particular we also have some really outstanding TAs who've worked very hard on the software engineering of the project. So I think that we'll be better in that regard this year than we were last year.
I actually had a question along those
lines.
Yeah,
Sure.
You mentioned that they're going to give the code to you and you're going to pass the code out.
Yes.
Do you mean just the code, or are you thinking, since this is structured more as a design review, that you'd really be talking about like a review package? It would be the code plus, I don't know, whether you're doing like documentation generation or any sort of an intro or front matter.
Yeah, so the question is whether in addition to the code there's going to be any other documentation or package or whatever. In fact, most of the final documentation is going to be for the final project and not for the beta. And so they should have things well documented within the code, for example, about what their strategies are and how they work and so forth. But there won't generally be a write-up. They should be providing you at your meeting with a brief outline of what's going on. And you can ask them after the first meeting for any other thing that you think would be helpful to them and to you in making the design meeting more productive. Okay? One of the things always in these things is how much do you require out of the students, at which time, and they have in this project, we're on a relentless series of deadlines for them. And so we've tried to do as much as we can while being still relatively minimalistic and asking for too much stuff too early. And so it would be great if they had a complete package of here's what's going on. The fact is that they were up really late the night before trying to get the stuff done. They've also had to submit beta tests. And so we decided that the final write-up of how their project worked, et cetera, we would save for the final. And it won't be, something in English written like that will only be in the code. It won't be as a separate package.
Right.
Oh. Any other questions about that? Okay. So one final, one word, relationships with students, okay? This is, so one of the things that MIT has, and many other places have, I'm sure you're aware, that if you're in a power position with somebody, and this in particular applies at MIT with students, you must ensure that all your relationships are strictly educational, okay? And what that means is like no romance, okay, duh, okay? But it also means in this context, no recruiting, hints at job opportunities, offers of summer internships, lab tours, et cetera, free dinners, and so forth, okay? Your job has to be completely educational. However, when the term is over, okay, you are welcome to continue your friendship in a non-power relationship. Okay, there's no longer a power relationship. You're welcome to, you know, start a romance with one of the students, if you will. Okay, but in particular, allowed to, you know, to seduce them to come to your company as a summer intern, or to, you know, or a job or what have you. Okay, so you're welcome to do that, but not during the term. Okay, those sorts of things are absolutely off bounds. Now, the students themselves may say, hey, do you guys have summer internships? And so forth. And it's up to you folks to draw the line and say, you know, say something like, yes, we do, but if you're interested in that, we can, you know, talk about that after the term is over, for example. Okay, so put them off in some way and return the conversation to the educational mission for the term. Yeah?
We're interested in that, do a good job.
Yes, but then you run the risk of it being interpreted as a quid pro quo for employment, which is exactly the thing that we're trying to steer away from. Okay, so, you know, they're smart MIT students. I think they'll figure out that if they are interested in a summer internship, they should be impressing their mentor. Not all of them figure this out, by the way. Okay, but
So just to clarify, it's okay to say, if you write your code this way, I won't hire you. But it's not okay to say,
I wouldn't hire you.
I just want to clarify.
You say, I wouldn't hire you. Okay, my company would not hire somebody who wrote the code like this.
Right,
You
but,
could say that.
but it's not okay to
Yeah.
say, my company looks for people who would write code this way.
No, I think that would be okay too. Okay. No, the issue is whether you personalize it, right? Okay. If you're interested in a summer job, okay, you know, I can get you a summer job. All you have to do is da 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 da, and now they feel like there's another master to serve. So what we want to avoid is having them feel like there's another obligation on top of the obligation they have to the class. They should not feel that in some ways they're obliged to do something for you in order, for example, to get a job. Okay? Or get a good grade. Or
if I say no to this summer job, they are going to badmouth me, and I will fail this class, or I will get a bad grade, and then so that will put them into a bind situation that they won't work for the class, but they will feel obliged to something else.
Right. You are in a power situation, and it is you're in a situation where you must not let them have any sense that there's any power relationship there. Okay, if you will. In other words,
We shouldn't try to extort meals from
for example, right? Exactly. Exactly. Okay. So, you know, as I say, you know, also if you feel anything awkward is developing, let Saman or me. This is something for which the staff-only email is better than probably the MIT POSSE one. Or even two of us directly, yeah. Although I think I actually think it's better to go via the staff only. It really is much better to go via the staff only because the TAs need to know what's going on with all the students in the class as well. Question back here.
Two logistical questions, but I don't want to interrupt you before you finish.
No, that's fine.
Okay. It's not clear to me, do we meet with the same 4 students throughout the term?
If possible, we will do that. Because otherwise what happens is they hear it from one and then they go to another, and you know, so this way there's some amount of continuity. But that won't happen perfectly because students will drop and we'll have to reconstitute groups and things.
The winners get David and the losers get me. That's okay. I just wanted to be clear. Also, you emailed the code to us before we do the sit-down session with
Yes.
us. Are we expected to review it by ourselves beforehand?
I think it helps to take a look at it, yes.
Yeah, so
It does
so
help.
we're not supposed to walk in cold and do it just then.
Yeah, yes, that's right. I mean, I think you do a better job if you have looked at the code beforehand to see, oh my goodness, this is, you know, and take a few notes. You know, it's, but for this, you know, we're relying on you to use your best judgment for what's the best way of giving feedback to the students. But I think generally, the reason we email it to you in advance is specifically so that you have a chance to look it over. Okay? Once again, we're not so concerned about whether, you know, the content of what they're learning in it as much as you look at it. It will take you 2 seconds as soon as you see one piece of undergraduate code. It'll take you 2 seconds to say, I don't care what this thing does, okay? This student needs to learn X, okay? I mean, you'll see. It just does. I mean, is that the feedback for people who took this for things?
When you see it.
Yeah. Okay. You know, any other comments from people from last year?
Yeah, a couple of comments. One, well, a couple of very minor, just sort of procedural things. Personally, I found it a lot more helpful, a lot more useful to me to show up in person for the information sessions than to do it by conference call, if for no other reason than that a lot of people who called in had issues with voice quality. You know, just getting a good quality voice signal over the phone. Also, I found it very helpful to have each student review the other one's code. So I would just do that to start with. Just, you know, hand it to each other and here, what do you think? And that also gives them some experience of of actually doing a review, as well as being, you know, the person whose work is being reviewed.
Yeah, it puts it. I mean, that's a great technique, just because it. One of the things that you want them to do is empathize with the person who's going to read the code. And so, you know, by putting them in the situation where they have to read somebody else's code, they very quickly learn, oh, this is, you know, I don't understand, my goodness, that's exactly what I did, you know, to the other one. So that is a great technique.
The reference implementations, are we going to get those?
Yes.
Soon, early?
Yes, those will generally, we will be able to give to you the reference implementations when at the information session.
Okay, and
or before. Actually, we should probably get it to them before the information session.
I would suggest before the.
Yeah, let's get those. Make sure we get those to you before the information session. We'll get you a reference implementation at least a few days in advance.
Okay, and also there was something that was a recurring issue last year regarding the reference implementations, which was that there were some issues with some of the reference implementations.
Yeah,
right.
In particular, things like functions that were not functions that should have been local to a file that were not declared static, or you know, that kind of thing.
Yes.
Or you know, macros that should have been used that weren't, or that were used that shouldn't have been. So
this time we have more. Last year we were running with a much larger class than we expected, with no infrastructure to speak of, and we had 2 TAs who were flat out, and so a lot. You know, we definitely cut corners. This year, the department has been good to us. We have 4 TAs, so I think that the quality is going to be high. That doesn't mean, you know, that the TAs are you know, seasoned. You know, 20 years of software development experience or more either. So they have some things to learn too. But already we're based on the first project, we're ahead of the game.
Okay. Also, if from time to time one of us wants to attend the class,
Feel free to attend the class.
Okay, where's the schedule?
It is Tuesdays and Thursdays in 26100 at.
Is it on the website?
It's on the website at 2:30 to 4. So Tuesdays and Thursdays, 2:30 to 4. You're welcome to come and learn all about performance engineering. Reed, did you have a question?
No.
Okay.
I guess I was just going to say that, I mean, regarding that feedback, you know, we TAs are here, I've got that.
They were in class last week. Most of the TAs were students last week. So if they haven't learned anything, then you'll be in trouble.
I'm sorry, where is the class?
It's in 26100.
Oh, it's not here.
No, so this is a situation where we outgrew our classroom, which seated 60, and we had 85 or 90 students. Okay, so they put us into the next the next smaller classroom that we would fit into. That was 26100, which fits 500. So we've actually found then we found that in 26100 you needed a microphone for the students to hear you, even though we had them all crowded into 1/4 of the auditorium. You still needed just the structure of it. You needed a microphone. So they said that'll be $85 a lecture. You say, what do you mean $85 a lecture? You know, so
Anyone has to walk in
yeah,
just to turn
on the thing. So So anyway, we sorted all this out, okay, but it was sort of funny that we thought that, okay, you're charging us for being in a room that, okay, that we have no choices to be in. Anyway, it was very funny.
Are your lectures videotaped? Are they available on
They are videotaped. We're not planning to put them up quick because what that does is it discourages students from attending the lectures, as you can imagine.
We are doing it mainly for OCW, OpenCoursera. So they will basically directly go to OpenCoursera, they will process it, and they have to go through a lot of legal stuff to make sure the images are right.
Are right and so forth, yeah.
Yeah.
So that there is a bunch of stuff there. Good. So it says final words here, but which is they aren't really final because we still have Eirik to talk about the first project. The feedback from the students last year was that the MIT Posse was one thing that made this one of their favorite classes. It was, getting that kind of seasoned feedback in a very small, group setting. Okay, when you look at the, faculty-student ratio or student-faculty ratio, right? That's one thing you're always battling, especially at MIT, where we're in a very popular major. And so the ability to recruit all you folks to help that ratio in favor of the students is really very much appreciated by the students and by us. So, so enjoy the term. This is really rewarding. The people who've done it before, we had just tremendously positive feedback from them about just how rewarding it was to work with these young programmers and such.
They are very smart people. You will see the changes. You will see the UI impact on them. You will see you're molding these people to become better programs. And that's the fun part.
So Eirik is now going to talk a little bit about Project 1. And this is similar to what we will do, although most of you will probably be on the phone, unless you heed Barry's advice, for the future one. So take it away.
So the Project 1, this is, I think, the one project that was substantially different from last year. So the code for this project, the TAs, coded up this semester. All right, so did we give out the handouts, Saman? Oh, or Charles? Yeah. So these are the...
So this is the actual assignment. And we'll share this with you, plus the reference implementation. I think.
Yeah.
I'm not sure I gave enough.
For the next... Yeah. We're going to set up... well, we'll send out the reference implementation tonight then. And in fact, now people have already done their betas for Project 1. Project 1 has two parts. It's a part called Every Bit Counts and a part called Tiling a Torus with Pentominos. So the first part is it's an abstract data type of modeling a bit array, packed bit array. And they are given a couple of tasks to do on long strings of bits. So you might have 8 million bits, and there are two functions to rotate a substring of the bits by some amount to the left or right. And the other operation is to count how many flip bits there are in a given substring. So the specific interface for this is an excerpt without the comments from the header file of this C module. There is a couple of accessors which accesses bits individually. Those are not, well, those accessors are currently used to implement in the reference implementation the rotate and count flips operations. So what they will need to do is to go into the C module, the implementation, and change these functions to basically be 10,000 times faster or whatever. I can't remember what they actually got In particular, the rotate operation is incredibly slow. There's one constraint for them, and we're saying that, well, imagine that this is on a cell phone or something where you have a really big bit array, but you don't really have very much more memory to consume beyond that big bit array. So we're asking them to only do this using a constant amount of memory. So that's the first problem with these two parts, the rotate and the count flips. Any questions about that particular part? Does it seem clear what? Yeah.
What does count flips do?
Oh yeah. So I should have swapped those two slides. So if you have a bit string, suppose 9 bits or something, 1, 2, 3, 4, 5, 6, 7, 8. It'd have to be 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, indeed. If this is the substring you want to count, then you count transitions from 0 to 1 or 1 to 0. And there are some neat tricks you can do by, for instance, considering
You count the number of runs of consecutive values.
Yeah, the number of runs, yeah.
Plus or minus 1, yeah.
That's right, right. Yes. And you don't count, the beginning or the end as a transition. So in this particular substring, there is, 1 there, 1 there, and 1 there. And it's not substrings, it's always substrings. It's not the entire string. And you can see that, for instance, you give as an argument the bit array, and then you say where the starting offset and the number of bits that the substring that a substring is, and that's where the operation is done. So our testing routines will do lots of rotations in different parts of that substring.
So your constraints, memory constraints, do you have a fixed size that they're allowed to use, or?
We decided against the fixed size. We just say don't use malloc, and you can allocate constant amounts of memory. And the thing is, if they choose to have a 16 megabyte or 4 gigabyte lookup table, then their performance will suffer anyway. So, yep. What's that?
Is there a particular architecture we are running?
That's right.
We are running it on. We got this donation from both Intel and Dell. We have 16 machines, I guess.
Yeah, 16 machines.
Each with 2 6-core processors and 48 gigs of memory. So they are doing it with 12 cores, so it becomes interesting when you go to Parallelism and 48 gigs. So we have a lot of memory in these machines, even though we asked them to restrict that. So these were the latest, what's the word?
Core i7.
Core i7.
Nehalem.
Yeah. For this first project, we're asking them specifically not to parallelize. So.
It's all on Windows or
Linux.
Linux?
Yeah. So the idea here is to exploit, bit operation, and in particular in rotate, the reference implementation does the really stupid thing of, okay, you want a sort of 4,000 bits to the right rotate. Well, I'll do it 1 at a time. That's the reference implementation. So, but they're only allowed to use a constant amount of memory. So there is a certain amount of tricks you have to do to do it in a more efficient way.
Do you stress in the course about portability of the code from one operating system to the other, one machine to the other?
So this is where we want you to stress the importance of it, because that's not something that we are in a position to do or enforce or what have you. Okay, so issues of, we can talk, for example, about, we let them assume for this problem, for example, that the machine they're working on is little endian. We talked about the issue, but we did not insist that they wrote code that would be, that would port to a big endian machine. Okay, because they're running on the Intel machines. But this is exactly the kind of thing where code quality would say there's portability, maintainability, readability, all these kinds of things. This is exactly the kind of thing we want you to say when you say, hey, you did it like this. In fact, did you know that you could have, without sacrificing anything in performance, you could have made it portable from one operating system to another. And then you can talk about those issues. And that's absolutely super to do that. But we are not spending a lot of class time doing that. We're really focusing on the performance engineering part of the course.
The reference implementation should be portable, right? So, and this should be portable, although we did make sure here, for instance, in the reference representation of the bit array here, that the order of the bits within each byte happened to coincide with the low endianness of these machines, so that if you happen to cast it to a 64-bit integer, each of the bytes in the array, then you would get something that was easy to work with on a low endian architecture. But the reference implementation is portable itself, or should be. So tell us any kind of problems with the reference implementation like that. The next problem is based on a puzzle. It's a puzzle solver. It's this puzzle that I'd never heard of before. Apparently, if you generalize dominoes, you get pentominos in the 5n case. So there are this many configurations of, well, dominoes with 5 squares on them, I guess. And the pentominoes puzzle is, you're given an 8x8 board with 4 squares crossed out, and now you're supposed to arrange these so that the entire board is filled up, and all the, what's that?
You can do flips of these.
Oh, right. You can do flips, you rotate.
You can take mirror images of it and all those things.
Right. So the task is find all the solutions. Although I believe that in our reference implementation that was too fast, so we decided to generalize the puzzle to the toroidal case where the board wraps around the edges, just to make it take a little longer to do.
Space Wars, right? You go off the right edge and come in the left edge.
Right.
Top and bottom also?
Yeah. Top
Yep.
and bottom also, yep.
So these two are both examples of solutions to this puzzle.
Eric, question here?
Yep.
Are you allowed to put the empty space wherever you want?
No.
Well, that's the input to the solver.
So you're given empty spaces, like given these empty spaces.
Okay, and then you have to fill the rest.
That's right.
And of course, you can put empty spaces so that it can't be solved.
And then they have to correctly determine that there's no answer.
That there's no answer.
Right.
Yes.
And also, I believe the reference solution takes days for certain to find all the solutions of certain configurations of the initial 4 dots. So there's an option to the program we give them to, just find the first 2,000 or something.
So once again, you can see this is conducive to bit tricks, where you represent the board as a 64-bit word, and then do masking operations and so forth to determine whether a piece fits, and do clever shifting to how do you shift. It's easy to shift the piece down 1 row, where you're trying it out, because that's just a shift by 8. But how do you shift it horizontally to come around on the other? So they have to do some shifting, some masking, and so anyway, that's kind of the first project is all about thinking about bit representations of things and so forth.
Yeah. In fact, we give them a solver that we don't really, a searcher, a routine to search the space of possible solutions that we don't really expect them to change, but they can change it if they want to. So the interface here is basically a board data structure that they're free to change the internal representation of. Or did we somehow prohibit that due to testing? No, that's the whole point, right? So again, you have this basic accessor for use by the testing routines. But then what you really need to, you need to change basically the entire implementation of all of this if you're changing the representation of the board, for instance. but this is the function that should be running faster after you're done. So I guess that comment is misleading. This is the function that is supposed to run a lot faster when you're done. There is actual comments in the header file. So right, you give it a function pointer to a callback.
One sort of standard thing we decided we're doing is we're not trying to write both 32 and 64-bit code in the class. We're just going to do 64-bit. So just it's one level. You know, in practice, you know, you would want to have stuff that runs both on 32 and 64, but for the most part, it's fine if they just have it running on 64-bit.
Right. So these, by the way, are the initial 4 points that are the input to the puzzle. So yeah, I believe that's the problem set 1. Questions about
Can students submit more than one answer?
No, they gotta decide what they're doing.
Yeah. I guess I have a question about valid answers.
Yep.
Is an answer that is probabilistically correct? Like, well, sometimes, or like when you test it, it happens to pass all the test cases, but mine isn't guaranteed to necessarily always solve all test cases. Is that okay?
If they can conceal that to us, then I think they
deserve credit.
Keep in mind that it's the other half of the problem set is to write test cases that will catch as many obscure bugs in the other student's code as possible. So they run the risk of competing against.
They lose extra points if they don't pass their own tests.
But each student writes some tests that will be as.
Yeah, so then they
assign somebody else's.
To somebody else's, yeah.
So we are running all the tests against everybody else. We are doing cross-product.
And then for the final version, we give them the full regression suite of the whole class, so that they have, you know, very good confidence, and we have good confidence that they're handing in something that that is correct.
Okay, so we want to open it up
for questions or
and
comments.
Also, especially, I want to invite the people who did it last time, who sponsored last time, to provide some of your feedback on how it was like.
Did I want to do that?
Wow.
Okay. I was trying to turn on the lights. Do we have more lights to turn on?
Just look like it's gonna
I don't know what.
Okay. Okay, you can turn this off too.
Good. Yeah. So comments.
Yeah. I mean.
Yeah.
So I was a master last year, and I had a great time, but I figured I'd say
I
talk about code.
Yeah. Can you stand up so people can hear you? Yeah. Thanks.
Yeah. Give me the mic. Give me the mic.
Yeah.
Because I think it would be good.
It'd be good to have these. Yeah.
Yeah.
On,
Yeah.
All right. Thank you. So the first thing I found really helpful was to take the reference solution and actually diff what the students provide, because they often just provide a solution, right? And if you don't know what they started from, it's hard to tell what they'd actually done. So like diffing the two, that was a good place to start.
Yep.
And then I found it incredibly helpful just to spend 15 or 20 minutes prior to actually meeting with them, looking at the code and writing like 2 or 3 or 4 things to talk to them about. And it might sound like it's going to be highfalutin and stuff, but it was like, they're returning function pointers to local variables, stuff like that. Like it was really. Like, or what the hell the make files were doing, for example, was like something that I think they really appreciated me telling them, and it didn't get talked about in class. So, and I eventually, once I got a good rapport with them, they just asked questions. I spent the whole time answering, more practical stuff about the problem. We had a good discussion, so that's what I would suggest.
Thank you. That's great feedback. Yep. Yeah. As I say, don't underestimate. I mean, most people learn. The kinds of things you're saying, but somebody told them that, hey, these are practices that really don't make sense in a real software system.
Or by the time we got to the projects, right? Like there's standard patterns that will have you represent, a bunch of flags, right? That you want to encode in a bunch of fields, right? Like, and if you've seen them a couple of times, it's just the standard pattern you do in animal.
Yeah, so one of the things you'll find on this first one is that they're very confused about the difference between unsigned and signed and how shifts work and what happens when, how come, I shifted this thing left 33 bits and I got a 0. Why you know, I thought I was shifting a 64-bit value, but in fact, they hadn't, you know, done one LL, they just did one. And so, you know, so there are things like that where they don't, you know, very low-hanging fruit, if you will, okay, to, you know, to talk about.
Did you tell them about Valgrind, by the way? Like, a lot of times it would crash. They said they spent a huge amount of time debugging the C, you know, these crazy C programs where they're not used to the compiler not protecting them.
Actually, that's a good point, because we were going to try to introduce, maybe we should do that as part of the performance, part of the next lecture, spend a little bit of time on Valgrind.
Yeah.
You know, because the memory checker there is really a pretty useful tool for them to get correct code. You know,
I second that. That thing has saved my butt so many times.
So many times, exactly. And yeah.
I've heard that. But more low-hanging fruit than Valgrind is to always compile with -w-all. To just catch all the warnings and declare all warnings as errors, and that just makes...
I think that we have that as a default in our make file. Is that right?
At least for the first project.
For the first project.
I think it should be...
Yep.
They should understand that in industry practice, that's... If you don't do that, you're schmuck.
Right. Right. Yep. Good. So that's good. And in particular, the Valgrind, we discussed that last year, and really, actually, the upcoming lecture is exactly when we should do that.
Actually, there's also a Dynamorio tool called Dr. Memory. I will see which one.
Okay, which makes sense. Yeah.
One issue that I found about last year was that one issue that I experienced a lot last year was that the students didn't tend to like write a lot of tests for their code. They mostly relied on a few runs by hand. They never could actually reproduce the things that they ran earlier. I guess that now you're actually encouraging them to actually have a test.
Yeah, well, so now they get points off if they didn't write enough tests that somebody else's code passed it that had a bug. So
and in this case, the testing round will be as part of the first turn-in, and then the second turn-in is just you have everything to run against, and then you just need to optimize.
Right, that's right.
So first one, they actually encourage they have to write a lot of tests because that didn't help, and the second they will give them all the tests. So they will have a large test suite to run, and then of course we have a large number of points we'll deduct if you actually fail those tests. Because they have no excuse.
There's no excuse at that point. It's just a question of having to run.
What other performance measurement tools are you going to be using this year?
So right now we are going to give them perf because what we found was the processor we got is so new. Lot of performance tools don't have, like O-profile didn't work because it haven't been ported properly. There's no port for it yet. So perf we are going to use, and we are thinking of giving them gprof in there. And then last year we gave them a couple of pin tools. We didn't ask them to write anything, but for example, count number of instructions. So a couple of tools they do that. Those are the main tools you get. And also when you go to Silk, we'll give a bunch of Silk tools in there.
Self-specific tools.
Yeah, I remember last year they were given btune, I think it was, and
yeah, we decided this year
it was too hard for them to use it.
Yeah, that was too hard for them to use because they have to use the machines remotely, and vtune is an interactive tool, and so that just made it very complicated to do things. So instead, we're going to go with a something that has textual output and is easy therefore to run from command line and has all the advantages of running things, that you get when you can run things from command line. Good.
So a logistical question. So meeting on MIT is fine, but where are there designated places to meet?
We will work with students to find places for them. I mean, for example, there are locations for TAs and students to meet, and we are going to get them arranged. So if when they are organizing, you guys can create probably online scheduling something. What's that website? Online scheduling. You can Doodle or something like that, and get their times. And then they will work on with us to figure out a place to meet, and then they can send it out. Basically, one thing we will have to do is between 4 students, if any project, because every project we are changing the pairings. So sometimes we might end up in a way that 2 of your students are paired together, and then we will tell you, don't put them together in the same group. You will basically have to mix them up in the other way. If they are not in any kind of a pairing, then you can organize the 4 in any way you want.
Yeah. Actually, I don't even want of the 4 of them. I don't even want us pairing them.
Yeah, but
that shouldn't be.
We will see
but we'll see what happens. Yeah. Barry.
Last year when I met, last year the course was in a classroom downstairs, and I just met them just outside the classroom. There's plenty of little spaces.
Yeah. Also, the first floor of Stata. I mean, we've had a lot of people just using the first floor of this building. There's lots of cafes and places there and so forth to sit there. Get a coffee.
Stuff like that.
And so forth. So, some people just did something that informally. Other people wanted a more quiet, private place to talk. And I think that's will help the students facilitate that.
And the key thing is, especially if any students are flaking out, for example, doesn't answer your email or miss the meeting or something like that, or late to the meeting, let us know, because there's part of their grade, even though you're not grading them, if they are not participating in working with you guys, they will get points deducted. So we really want to know that, and we are trying to emphasize that they have to act and actually do it right. So we really need to know that if the students are not actually cooperating with you guys.
Yeah. So I hope that this year we'll have a better. So the vast majority of people last year had no trouble, but we did have a couple of people for whom it was, one or 2 students who just made sort of life a little miserable for their master. And so, hopefully we'll provide a few more incentives this year to avoid that situation. But they're students, and so they,
Okay, when do we find out which students are assigned to us? And
probably within the next 2 days.
Okay, and
yeah, within 2 days.
Okay, and then who's responsible for contacting whom?
That's a good question. Who should which direction we should?
We decided that, didn't we, at the meeting? When did we decide?
This is what happens when you don't write things down.
Yeah, no, right.
You have to commit our own stuff. Okay.
So we did not want it to be. Let's see. So last time I think we had it that the students contacted the mentor, and then.
Yeah. What we will do is we will send the intro email to everybody. We will send intro email to the mentor, CC the students, and say, "Hi, I'm introducing you each other." And then one thing you can do is immediately reply, and if you have create a doodle poll or something like that, and then say, "Okay, look, let me know where is your availability." So you can reply to that, and hopefully they will reply back and proceed. So we will send you, when we send you the names, we will also CC the students. So
are people familiar with Doodle? Anybody not familiar with Doodle? Okay, so Doodle is a website where you can basically enter a whole bunch of times, and then people enter their names and mark off which times they can make things. So it's a poll. It's an online poll.
Don't do what I did last time. I marked off all the times that I cannot participate, so I just basically give the exact complement.
It's green and red. Okay, is what the colors they use. So green means you can make it, and red means you can't. So anyway, you don't have to use that facility, but it is a convenient one to use.
Oh yeah, there will be people dropping. They just started, and even after first project, I mean, this is also a group project, and at 2 a.m. we got mail saying, okay, I'm dropping the class, and we had to kind of scramble, trying to at 3 a.m. to create another group, and so yeah.
We should take it upon that as a reflection on our. People drop it.
Yeah.
We have done enough to know that
you can if you want. Yeah. Yeah, no, that tends to be more.
I have one student that is awesome.
Yeah.
To get an idea of the mindset the students are going to be in, is this sort of a really tough 6170 type thing, or is this one of the easier classes?
No, this is a challenging class.
So you take 6170 that has about 4 projects. we double the number of turn-ins. So because each project
we have a
has
beta and a final.
Beta and a final, and some projects have 2 turn-ins in there. So basically, they have overlapping projects going on because they are doing the new project and they have to submit the final of the previous project. And they're already, we give them a project 0 that was
just like real life, huh?
Yeah. We gave them a project 0 that was due to get them to get used to the system. And we can half into the class, they have to finish this one. So this class just screams and accelerates very, very fast.
Yeah, and of course, they're students, so they don't, some of them have learned, you put off things to the end and haven't learned, the lessons of, well, not always, So as I say, they're relatively, as a group, they're relatively immature when it comes to some of these things. But there's a large fraction of them who are, incredibly mature about these kinds of things. So, our job as lecturers in the class is to make it so that the students who start work early don't get penalized. Okay, and that's probably the hardest thing in a software related class, because the classic thing is that the ones who get started, okay, they find all the bugs, right? And they waste their time doing it. And if you do it later, then the TAs have worked all the bugs out. So our one of our challenges is to make it so that students who start early are rewarded by being able to have more time and not wasting their time.
And today was the day that they turned in the project, and by looking at the class, you realize they haven't gone to sleep. And I asked, most people haven't slept in about 30 hours. They have been up entire last night. And email conversation, when I went to sleep, there was an email train going every 5 minutes, something pop up. When I woke up, this train was still going, and amazingly, there were a couple of TAs up and answering all through the night. And that kept continuing. And so these kids, they can be flaky sometimes, but they are amazingly hardworking. And this is only one class they are taking. Right. They might be taking 4 classes like that. And I have seen people scheduling their schedules by the hour, scheduling, and they say, okay, look, I can do your problem set, or I have 1 hour of sleep. And a lot of times that's their thing. And sometimes they triage. That's why sometimes they miss classes and stuff like that. They realize, okay, I can do the problem set, I can sleep, I can do that. So I think these kids work amazingly hard.
Yeah.
But
I do think it's helpful to also counsel them on, hey, you can't do everything on a death march. Okay, you got to learn at some point, what you're capable of and manage your own time resources and so forth. Because the joke at MIT is what classes, friends, sleep, pick 2. Okay, so the other thing, let me just say, is that despite the obvious sleep deprivation we saw in the class today, the number of students who came up after class so charged about working on this first project was really quite amazing. Okay, they were all very, very excited. Very excited. We also gave them the initial feedback on the performance, and you could see there's one group of students who clearly got it, and then there's another tier where students who didn't get it quite as much, and then there's the ones who their code has errors and stuff. So there's no doubt that there are a lot of students who are very charged about this. This is a fun class. Okay, but it's a hard class.
Yeah, I think you'll find that in the students too. They will be probably tired, but they will be soaking up this information like a sieve. And sometimes I found last year's after looking at the first set of code, some of those masters were really upset. It's like, how can you teach these guys write this kind of bad code? But what they realized after they said something like, look, this is getting into their heads. They're improving, they're actually changing. These guys are very smart. Yeah. And they are looking for you guys it's basically sponge. Just like really empty sponge. They're going to absorb a lot in this class.
Yeah, I have a 2.5-year-old at home, and it's amazing what the progress is she's made in 6 months. It's just, she's talking now in complete sentences and so forth, and it's just really amazing how she does it. And these students are like that, okay? They start out and you say, oh my God, they have no skills. By the end of the term, you know, the progress that they've made is really astounding. You know, you just say, gee, if you could just keep on that trajectory, you know, your whole life, okay? But really, they really are very smart, and they come up to speed very, very fast, especially given, you know, good counseling. The main thing that they need right now is just the attention so that somebody actually can look at their code and say, you know, if you did it like this, it would be, you know, it'd be better code. Good. Any other questions or issues? This is lots of fun. If you run into any troubles, you know, we're right here. You know, just send us email. You know, as I say, they're young and immature, but you know, then you get to see them. You know, you get to see them grow. Of course, some of them, you know, will flake out on you. You know, but the vast majority you'll see are really very you know, dedicated and well-meaning. They really want to do a good job in the class and really find the class very exciting. Our numbers, in fact, like almost doubled from last year, yes, right? You know, so the reputation got around that this was, you know, was a good class to be doing. And the other thing is that given the way, you know, right now, what I really like about the class, the students right now compared with, say, 10 years ago. So 10 years ago, we had the internet boom, and there were all kinds of students taking computer science because they thought it was a ticket to, you know, fortune and so forth. And now we're back to what it was pre-2000, 1998, whatever, where the vast majority of students who are taking the class really enjoy engineering. Okay, they really enjoy the software. They really enjoy the engineering, and the fact that it's, you know, you end up with a pretty good job and you know, opportunity sometimes to do entrepreneurship and opportunity to explore things is sort of like, oh, that's a fringe benefit, but what they're really after is just the intellectual excitement and so forth. So it's really quite fun to work with these students and quite rewarding. Really very nice type of class to have right now, where the students are taking it because they're actually interested in the material, not because it buys them a bread ticket, you know, meal ticket, whatever. Yeah, question.
Is the standard, is the coding style in the reference is the standard we should consider for them for guiding?
I don't think we have set up a standard per se. What we want them to do is kind of create their own style. It's like in a writing class. You don't give them a standard writing guideline as a follow this one. I mean, you don't want to constrain them to that. And we want to give them the opportunity to grow into their style, but kind of guide them into it so that they don't make the classic mistakes in there. So that's why this class is. That's why we need you guys. I mean, if there's a standard, we can publish a standard, create a script to actually check the standard, and we say, okay, thou shall follow the standard. And you can do that, and everybody will hate it. And if you don't adapt, I mean, you can't make them adapt. And one thing we want to do is make them lifelong good coders, not something they realize, okay, I need to do this to get this grade, and I'm going to abandon everything and convince myself never to do that again. And we have had sometimes, like when you did early software engineering, we went through things like, thou shall write all the precondition and post conditions, and everything will be graded. And people did it, but half them got into them and said this is a good thing. Other half didn't realize why they are doing it. They just hated it. And I don't think that they left with assuming I will never do this again. So the key thing here is we don't want to force something onto them. We want them to come through a natural process, and I think a lot of them when they understand what they're doing, will develop a really good kind of practice.
It's also the case, I think, that you know, coding standards vary culturally from place to place, and what people expect in one place is different from what's things. So being too prescriptive means, you know, as Saman is saying, that it becomes a sort of grammatical thing rather than is this code organized? The real thing, you know, is coding standards are very important, especially in large software organizations, of course, so that everybody can tell what's going on in any particular piece of code without having been the author. But in this kind of thing where we have something that's relatively small, what we're mostly interested in is the organizational aspects of coding style as opposed to the grammatical the grammatical ones.
So also don't impose your standard. They say, my company, this is what we do, I want you to follow that. Just figure out and kind of guide them towards something what they are maturing and trying to make it better. I mean, that's the thing. That's why we cannot have a cookie cutter model into this.
Yeah, and why it's good to have senior software engineers who, you know, understand that you know, what's really important, you know, as opposed to you know, what you know, what might be required in any particular individual situation.
One other topic I want to add is sometimes when you have two students, there might be a case that one person might be very talkative and dominating and one person might be just a listener, so you have to keep an eye on that and make sure that you give the other person opportunities to talk and get them, because there might be cases like that. Encouragement and stuff like that. So make sure that you get both of them talk, and also they are supposed to be responsible for all the code. You should not let them get away by saying, oh, my partner wrote it, so I don't understand, and so that's not a good answer. So get them to actually go through that. And if they don't come prepared, tell them that, and you can give them some feedback and say, next time, can you please do this and this, and because they also don't know what to expect. And we gave them a little bit of guideline, but it would be good also for you the first time round, if you find some mistakes, kind of also for the next code review, you can encourage them what to do, how to prepare, and what to do. Don't give them too much work, because we are already giving them enough work. Don't ask them to write extra documentation, but you can say, oh, it would be nice if you had this level of preparation, if you could have explained to me or given me a summary or something like that. I mean, so something like that is something you can expect. And other thing is, if you have to figure out how you want to do code review. So for example, you might want to bring your laptop or ask them to bring a laptop in there. If you want each other to look at the code on the computer, so ask them to bring the laptops or something. So think about the logistics of how you're going to do that, and that would be useful.
Yeah, and I think any other sort of expectations you have could just, you know, in your email to them the first time, say, you know, here's what I'd like you. I think it's helpful to say I'd like you to come prepared to give me a 5-minute update on how you did each of the problems, for example. Okay, we will be telling them that, but to have it come directly from you means, oh, you know, the difference if I say go do this to that person versus you're coming to me and expecting it. So good. I want to, once again, I can't thank you folks enough for being willing to give your time. Time is the stuff life is made out of. So I really appreciate your willingness to volunteer your time for these students. And I really think you have a dramatically meaningful impact on the students. And the students may or may not fully appreciate that, okay? But Saman and I really appreciate that, and we will make sure the students appreciate it. Yeah.
What are the guidelines for contact outside of the code reviews with the students? I mean, can we have them email us with questions about
sure.
the process and just kind of
it's your level of tolerance. We don't want you to have to commit more than about 20 hours across the term, because then, you know, it becomes onerous. But if you're willing, you know, I think it's completely open-ended in terms of how much else. I don't view it as, you know, I mean, it's one thing if you go into solving their problems for them. That we don't want you doing, okay? But when it comes to, you know, especially the quality and non-metrical aspects of programming, the more you can give them, the better, okay? Because it's only making them be better programmers. And I think the fact that there may be some unevenness in that across the masters is irrelevant. Really, you know, it's sort of like I do not want to hold back some student from getting good mentorship because somebody else is not getting the same, you know, level of attention, et cetera. So really, but really, no expectation there on our part to do more than the code reviews themselves.
So that said, I would want to make sure that you are not answering their questions. At some point, I don't want to be a crutch for them. And like, for example, if they say, okay, before pre-beta, if they say, okay, this is my next problem, can you help me on a little bit? I don't understand. If you have that, so if they're trying to get too much into that level, kind of making you their programmer or something like that, just let us know. So it's a lot of these things, there will be a lot of cases that arise that we haven't thought through. The students are ingenious enough, they will find a lot of loopholes, a lot of kind of interesting things that we never thought through. So if you find something that you not feeling comfortable, just send a mail and say, okay, look, this is the
if it really is, if their questions are about course content, it's not appropriate for you folks to be dealing with, really. Okay, that's what our TAs are for and the course staff. If it's about coding, style and engineering practice and even time management or anything that's sort of the non-technical aspects of but things that have a strong impact on the technical. That yes. Yeah. Anything you can provide there is great.
So I think if you find anything that's outside the norm of it discuss, if you feel a little bit uncomfortable, just send an email. Send an email and say, hey, can I do this? It's okay for me to do that, and we can always provide a guidance. So we are responsible.
If you do something and say after the fact, oh, I went past, let us know. Okay, there's nothing. There's rarely anything you can do on a one-shot basis that is is heinous or unrecoverable from or whatever. So.
Yeah. It's always good. I mean, that's why. So since we see everybody and we have done these kind of situations before, we can just easily tell you what.
Yeah, but mentor them. They're for sure mentor them.
I think a lot of times when I talked to students last time, they got a lot more information out from you from the masters other than just a coding style. I mean, they talk about what is it like to be an engineer in a company, what are the things, and then so they got a good feel. I mean, some of them might not have done an internship in a company, so they don't know. I mean, they are just screened and talking to people, you guys. I mean, they get a feel for what's like, and also from a non-marketing situation too. I mean, you might have ulterior motives to market your company to them and stuff, but this is not that they are going into job interview. So this for a lot of them it's rare. I mean, they might not have relatives or friends that they can go and talk at that kind of casual level. Most of the time they are on guard because they are on interview, or they assume that the information coming to them would be sugar-coated. And here's a way that they can get. I think this is very valuable for them.
We're 8 minutes over time.
Okay, I think we should.
So any last final comments? Otherwise, so Saman and I will hang around for a few minutes for anybody who wants to chat more one-on-one. And once again, I thank you for all the time that you're planning to put into the 6172. Thanks.
Thank you.